Okay, hi and Assalamualaikum. My name is EC1101K and now I'm going to explain about our topic, which is integration. So in this topic, I am going to explain about the meaning of integration in calculus and its application in real world, especially in civil engineering profession. To begin with, integration in calculus is basically a form of technique to find a function fx, gx, y, and so on. This is integrated by this symbol, as in the equation written like this. It is usually called as indefinite integrals of the function. The definite integral, written as this equation given, where b and a are the limits. Now that I have explained about the definition of integration, let's talk about the application of this technique. As an engineering student, integration is being used to find many things in this division, such as the length of certain curve, the area between curve, volume of solid of revolution, moment of inertia, and centroid of an area. Okay, so now let's take Golden Gate Bridge as our example. Integration is being applied on finding the length of central span of the main cable on the both sides of the towers. Another example is integration is also being applied to find the area between the curved line and the straight line. The area can be calculated using the equation given. So let's conclude my part on introduction of integration. Now let's moving on to the next part, which is problem statement and solution presented by my teammates Faizatul Azhana and Nur Alia.
Assalamualaikum warahmatullahi wabarakatuh. Okay, now we are going to take the indefinite integral of 4x to the power of 3 over x to the power of 4 plus 7 ds. So, how can we tackle this equation? Now, the key inside here is to realize that you have the expression x to the power of 4 plus 7, and you also have its derivative up here. The derivative of x to the power of 4 plus 7 is equal to 4x to the power of 3. Derivative of x to the power of 4 is 4x to the power of 3. Derivative of 7 is just 0. So, there is a big clue that U substitution might be the tool of choice here. So, given that, what you want to set your U equal to? So, we could set U equal to x to the power of 4 plus 7. Now, what is du going to be equal to? Du is going to be the derivative of x to the power of 4 plus 7 with respect to x. So, for x to the power of 3 plus 0 times ds. But it is a complete equivalent statement to saying that du, the derivative of u with respect to x, is equal to 4x to the power of 3. Our integral we can rewrite as 4x to the power of 3 dx over x to the power of 4 plus 7. And then it's pretty clear what is du and what is u. U, which is we set to be the equal to x to the power of 4 plus 7, and then du is equal to this. Du over x to the power of 4 plus 7, which is u, or we could rewrite this entire thing as the integral of 1 over u du. Well, what is the indefinite integral of 1 over u du? That is going to be equal to the natural log of the absolute value. The natural log of the absolute value of u, and then we might have a constant there that was lost when we took the derivative. So that is essentially our answer in terms of u. But now we need to unsubstitute the u. So what happened when we unsubstitute the u? The natural log of the absolute value of u is x to the power of 4 plus 7 then plus c. So this is the final answer.
This is the second example for our chapter, which is integrate. So I choose this question about area. So the question is find the area bounded by the curve gx equals to x squared minus 1 and the line fx equals to x plus 1 as shown in the figure below. This is the figure. So we need to find the region area. So we need to use integrate with respect to x because it is respect to x. Before that, before we can find the area, we need to find the lower and upper limit. Because to find region area, we need to find upper and lower limit. So we can find with in this, which is intersection points. We can solve with simultaneous equation, which is x squared minus 1 equals to x plus 1. So we calculate it and we get x equals to -1 and x equals to 2. So as we all know, x equals to -1 is the lower limit and automatically the x equals to 2 is the upper limit. So after that we can insert it in the equation. So area equals to integrate to -1 x plus 1, which is the line, the straight line, minus the curved line, which is x squared minus 1 dx. So we calculate it. First we simplify and expand and simplify the question first. Then we integrate. So after we integrate, no more integrate sign after we integrate. So we substitute the number 2 and -1 in this expression. Then we solve it and get the area of R, which is 9/2 unit 2. So I think this is only for me for this question. Yeah, thank you.
Last but not least, after all my group members present their respective sections, then now it is my turn to present my sections. So, I will present a conclusion for this topic. We have seen that in situations where it is impossible to know the functions governing some phenomenon exactly, it is still possible to derive a reasonable estimate for the integral of the function based on data points. The idea is to choose a model function going through the data points and integrate the model functions. The definitions of an integral as a limit of Riemann sums shows that if you choose enough data points, the integral of the model functions converges to the integral of the unknown functions. So, theoretically, numerical integration is on solid ground. We have also seen that there are many practical factors that influence how well numerical integrations works. Simple model functions may not emulate the behavior of the unknown functions well. Complicated model functions are hard to work with. Problems with the number of data points or the way in which the data was collected can have a major impact. And while we have explored some simple ways of estimating how accurate a particular numerical integral will be. This can be quite complicated in general. Nonetheless, by using common sense together with a solid grasp of what the integral means and how it is related to the geometry of the functions being integrated, a creative scientist, mathematician, or engineer can accomplish a great deal with numerical integrations. Here are some of the references we refer to in producing these video presentations. So that's all from our video presentations. Thank you for watching. Have a nice day. Bye. Assalamualaikum.